I was going to do this as a pre-recording, but all my camera equipment has failed. So I'll do a live stream and maybe break this into two parts because I want to just talk about two fundamental issues, really, in order to reverse engineer the globe Earth belief and see how it's actually it's just how it's formed from a level Earth in the first place, or at least how you can do that. I'm not making a claim as to this is how it was done, but it's easily done. If you're new to the flat Earth, or you may have heard it and just kind of fobbed it off as some crazy conspiracy theory, maybe you really haven't thought about it that much, but so-called flat earthers have thought about it and thought about how the globe concept was arrived at in the first place. And you do eventually reach the conclusion that it is a belief. And so that is going to kind of start off with that first. And then I want to talk about latitude lines and some different locations. So basically the latitudes that are based on the altitude of Polaris from any given location, and how we can then, discern distances on a level Earth. So a couple of things to think about. First of all, when we're given this picture of a globe Earth, if you say Earth, the first thing that pops into your mind is a globe, because that is the concept that we've been given. If you look at a globe, most of the land mass, or the known land mass, is pretty much on one side, and you have this other side that's mostly water. And as a consequence, you don't really get much traffic going to those parts of the Earth, that other side of the Earth, because there's nothing there. According to the maps anyway, it's just water. So most of the commerce and the commercial routes or the traveling is done across the land masses. So there's not much traveling across this vast area of ocean. We also have Antarctica at the bottom, which is obviously a bone of contention. And do not be mistaken that this idea of a flat Earth with a North Pole at the center and an ice wall is what people alternatively believe as the flat Earth, nor is it correct to assume or tar everyone with the same brush that has certain models that they adhere to. It's really not anything that anyone can really know. And this is the crux of the issue, that there's a limit to what we know, and what we know is what we see on the maps. None of us will really get the chance to go to some of these almost inaccessible places. Plus we have, for example, Antarctica, depicted as just ice, basically, not actual land. So it's an entire continent that's made up of ice, apparently. If you also look at a map of Antarctica, you'll see that you have about a third of it or more that is segmented into these different portions of land that belong to these countries that are on a similar longitude. So that longitude line from north to south, for example, the UK, there's a strip that belongs to the UK and Antarctica that's almost in line with the UK. There's Denmark, there's France, there's Germany. Other countries, Argentina, I think, has a slice of Antarctica. So that part of Antarctica is divided up there into those territories by countries that we already know. But there's about 2/3 of Antarctica, if I'm not mistaken, that's basically no man's land. And that 2/3 it goes out onto that ocean that doesn't really have any land on the globe Earth map. And how many of us are ever going to actually go and verify that? All we know is the maps that we're shown. A few of us in our lifetime might get to go to Antarctica. Has anyone ever been to the North Pole, really? there's so much that we don't know. Also, if you consider how compasses work with the magnetic field, they are pointing north or south, if you like. How would you know which direction is which, to be honest? But let's just say, for the sake of argument, that there is a North Pole where it is claimed to be, or maybe a little bit further, or off to a different, slightly different few number of degrees than where we might think of it, but who knows? Again, people aren't really going there, but we can pretty much put a North Pole at the center. And of course, the further away you get from the North Pole, then if it's a magnetic influence, then that magnetic field will eventually die out, and then you would get to the South Pole, and that would just be really beyond the reaches of where the compass is pointing in any particular direction. So one of the first things you find out when you start looking into flat Earth is that, well, it's easy enough to do to look up records of circumnavigation around the circumference or the equator, east to west on the Earth, but no one's ever gone from north to south and then cross and back up to the north again. No one's ever done that. There have been some pole-to-pole flights, but they don't exactly go in a straight line. So no one's ever done that. So there's a big question mark there as to why hasn't anyone, if it's easy enough to go around the globe, why can't someone go the same distance around north to south? Many anomalies to consider there. So, that can bring us on to the first part of what I want to talk about, which is making a globe from a flat Earth. Welcome if you're in the chat there. I want to basically get through this presentation first and kind of get down the things that I've made notes for, and then maybe we can talk about it. So I hope you don't mind, just chill, chat amongst yourselves or whatever, and I'll have a look at the chat later on. Yeah. So first of all, just here's like a godlike view of the Earth. We're looking down on an infinite Earth. Consider this whiteboard an infinite Earth. There's pieces of land here and there. There's surrounded by water. Okay, and we don't know all of this. We just know a portion of it. That's what you can consider the flat Earth to be. Just a portion, or sorry, the globe Earth. You can just consider a portion of that. So I've got what I've designated as the North Pole in the center. And why not? Because that's where we've got Polaris on the Earth. So if you just have a look at this, it's easy to see what that is. It's just a template from a piece of paper to make a cube. You know that you've got these 6 squares here, which can be folded up, okay, to make a cube. Yeah, so there you go. I've got myself a cube Earth. All right, what will be a cube Earth? Yeah. So here's our level Earth, and so consider the globe as just a net or a mesh or something that's been put over the Earth. I'm using a cube here because it's easy, but there are templates, origami templates for making spheres as well. So that's basically the same principle. Yeah. So what, of course, I could do here is just place my boundaries, the boundaries of my square, my cube that I'm going to make, over this level Earth here. All right. So as you can see, that is what's going to be included into my cube Earth in this case. Okay. Anything outside of this cube or this layout is not known. It's not recorded. So we would superimpose all these bits of land onto here. Okay, we've got our North Pole right there. Okay, and we put them onto our cube here. I could draw them on, but you're good at using your imagination, so you can do that yourselves. Yeah. All right. So boom, I've got my land and I've got my North Pole, and the South Pole is just going to be basically another point that's at an equal distance. We've got the dimensions of our cube worked out already for our scale, and we can then just put the South Pole wherever we want, really, you know, or at a certain distance from the North Pole where things start to be less clear about as far as magnetic north goes. All right, and then so from that I can then of course create my cube Earth model. All right, I started with a level flat surface. I put a template over it, I put some boundaries over it, and then I wrapped those boundaries into a cube. So of course you can do that with a globe if you want, right? You can make it into these sections or petals if you like. Yeah, we could just have a quick look at how that might be done, and this will help kind of explain things for later on as well. So for example, I had my South Pole here. All right, so what we could do is we could have a radius from here. Okay, we'll do something similar there. All right, so we've got a certain distance from the pole, and this is going to be to our equator. All right, so here is our equator. All right, and we'll have a radius. Yeah, we've got these quadrants here. Okay, yeah. So this is basically the northern hemisphere, if you like, of the globe, and it's just, we've got the equator there. All right, so of course the mathematics, when people say, oh, we worked out it was a globe, the royal we worked out it was a globe 2,000 years ago, or Eratosthenes did, you know, well, all you need really is a distance from the North Pole to the equator. And then, of course, you can take that radius, you can multiply it by 2 to give you the diameter, and you can multiply that by pi or 3.14, and you get your circumference, okay? Easy enough to work out a circumference. So this is the one thing you get with a rigid mindset is a circumference certainly doesn't mean that you're talking about a globe. You can work out the circumference there, yeah? So, of course, you could then just... So we've got our dimensions here now. We've got a certain number of kilometers or miles or nautical miles, and we'll see why nautical miles is used in a minute. But you've got your radius, okay? So then from that, you've got at least half of your mathematical model. But then what happens, of course, let's just extend that radius. We just do the same radius as we have here, add it onto here, and that takes us to our South Pole here. Now, this doesn't have to be any specific location that we've actually physically been to. We've already got all the information we need, and we can just draw another imaginary line to that point. Now, of course, if I did another circle going out, we've added the radius here, we have the radius here, we have the radius here. So, of course, that then gives us this much bigger circle and a much bigger area. So of course that doesn't really work as far as a globe goes. But if you remember when I put this on, basically anything that wasn't within these boundaries was just ignored and cut out, whether it's there or not in reality. So as you can see, we've got these cheese wedges. You can just make some more cheese wedges if you want, and you could do them any way you like, really. But I'm just doing this for illustration purposes, just to help understand the concept. You can see that we've got these petals here, which you would then turn into the base, the southern hemisphere of your globe. So you've got your northern hemisphere up here, and then beyond that, beyond the equator, is your southern hemisphere. Of course, it's not a hemisphere. It doesn't have to be a hemisphere. It's just beyond the equator. And so these points here would join to be the South Pole, opposite to your North Pole, just as we had in our cube. We had a North Pole up here, and then you'd turn it over and you'd have a South Pole on the opposite side. It's all basically calculations, and mathematically it would work because you've presupposed a cube, or you presuppose a sphere, and you've got certain measurements which you then extend. So yeah, all this land and sea totally ignored, not part of our picture, not seen on any maps, not seen anywhere, never talked about. So how would we know that any of this exists? Most of us would never really go much beyond the equator anyway, or we might go to a place beyond the equator. Let's say that, we've got, it could be South America, or it could be going down from Africa, and then South America, then you meet Antarctica. That could be a landmass, all right? So it could be the shape that we're shown, but there could be just so much more beyond that that is just not part of it. It's not part of our globe projection. Yeah. So by now it's looking a bit messy, but you kind of get the point. So all of this land is like it doesn't exist. It doesn't exist. It's there, but in our globe prison, it doesn't exist. Yeah. And that would be the same for a flat Earth with an ice wall, that's contained and what have you. I don't necessarily promote that kind of thing either. And again, I'm just showing how it's possible to take a level Earth, or a portion of a level Earth, and change it into a globe Earth, which would be this kind of objective view of our Earth. And of course, it would appear to be more of a scientific approach, because we're not assuming that the Earth is the center of anything. We're not assuming that it's created by anyone. We're just assuming that it's an accidental fragment or speck of dust from a big bang. Excuse me, I've got to sip some water. So hopefully that has kind of helped clarify some of that. We can just We'll talk about this later, but what happens is when we're talking about distances, we've ended up with nautical miles, and so nautical miles equals 1 degree. So this is part of this whole turning everything into degrees is all part of it. We've got latitude locations, which are talked about in terms of degrees. And so that means that distances across the level Earth are converted into degrees. And of course, then with degrees, you can assume that these degrees are part of a circle. And of course, you've got your longitude lines, which are, or longitude, however you're supposed to say it, which are going north to south on the globe, right? They are just divisions of time. Again, you can just add those. So, let me just scrub this to show that, really, just as a thing there. Let's see if it makes sense. Oh, we're going to lose this if we might excuse us. Very precarious setup here. All right. All right. So we were looking down on a level Earth, yeah? We've got our North Pole there, and then so distances from the North Pole would be latitude, yeah? Okay. And so the equator ends up being zero latitude, yeah? So this is, we've got polaris above, and then things go beyond that. All right, so the other thing you can do is then divide it up into segments which are longitude lines. And again, longitude is just talked about in terms of degrees because we're talking about time. Yeah, so the time is considered as a circle like that. You've got 360 degrees, hence using nautical miles as the unit of measurement or calculation, not because because basically kilometers or miles don't really fit into this, but nautical miles, just coming up with this unit of measurement allows you to illustrate 60 nautical miles in distance as 1 degree, or minutes and seconds of time as well for your longitude. Yeah. So of course on a globe, if we then kind of talk about a globe with a North Pole here and a South Pole here, your longitude is your north to south line. Yeah, your latitude is going to be these lines here. So these are the lat, and that's the longitude down there. Boop, boop, boop. Yeah, they're going to do this kind of thing. Okay. Yeah, just to be clear what those aspects are. So just where you want to focus on the latitude and distance. Yeah. So it all ends up being degrees, right? So as I said, I will turn this into two parts. So I'm just trying to bring that chat up here, if it's coming up at all. I can't see it. I can't see the chat. So sorry about that. If you're chatting away, I cannot see it. Okay. I'll tell you what I'll do is I'll stop it there because I'm going to I do want to convert this into a two-part video anyway. Let me just see if I can. No, I can't stop. Oh, I wish I could see the live chat. Okay, never mind. Yeah, I'll stop it there and I'll set things up for the next one, and I'll go live again in a second, and hopefully this time I can get the live chat working. All right, let's try that and see if that works. Okay, back in a sec.